Good evening, everybody. This is Euclid Book 6, Proposition number 22, Part 1. And we're going to talk about something called reciprocally proportional. And do not ask me to pronounce that again. It is a real horrible thing to try to pronounce. But here's how this goes. Now, you see this triangle here? We're going to label it A, B, C. Okay. Now this should look very familiar to you because in a previous proof we had a situation much like this. Okay. Matter of fact, I drew this exactly the same way as I did in that previous proof. So this should look very familiar to you. We have a triangle and it's called A, B, and C. We have a triangle here that's called D, C, and E. Now this triangle here and this triangle here are exactly the same size. Now what does it mean by reciprocally proportional? Okay, what that means, you see this line called BC? Okay, line BC belongs to ABC. Okay, let me say that again. Line BC is a part of the triangle ABC. Alright? Now, what they're saying in reciprocally proportional is this. And you can't see that. As 2 is to 1. Well, this line here is 2 inches long. And the line DC here is 1 inch long. Now, line DC belongs to triangle DCE. BC belongs to triangle ABC. And DC belongs to triangle DCE. So, as 2 is to 1, so is, now see line CE right here? You see line CE? That's 2 inches long. Line CE belongs to triangle DCE. Now you see CB, I'm sorry, CA, you see this line here called CA? Well, CA belongs to triangle ABC. So, as BC is to DC, which is 2 to 1, okay, so is CE, which is 2, is to AC, which is 1, which of course is true. And that's what they mean by reciprocally proportional. As this line is to this line, so is this line into this line. And that's what they're talking about in this proof. Alright, now let's go on here. Now you could actually have a situation, let's say that this triangle here, hypothetically, was twice as big as this one. Let's say that this was actually 4, we're just going to circle the 4 here, and let's say this one was actually 2. Okay? Then reciprocally proportional still holds true. As 4 is to 2, so is 2 is to 1. Because 4 divided by 2 is 2, 2 divided by 1 is also 2. So that would still hold true. They're reciprocally proportional because as this line is to this line, so is this line is to this line. And that's what they're saying. Okay? So let's go on here to this proof right here. This, of course, is Euclid Book 6, Proposition number 22. I'm going to try to get this as much as I can. May have to turn this around just a bit. Okay. Now let me read you this proof. It says, if 4 straight lines be proportional, the rectilineal figures, these are rectilineal figures here, 1, 2, 3, and 4. All 4 of them are rectilineal figures. Now I know that these look like parallelograms here, which that's exactly what they are. And I know these look like triangles because that's what they are. But they're all 4 rectilineal figures. Okay? If 4 straight lines be proportional, the rectilineal figures similar and similarly described upon them will also be proportional. Now there's a second part to this proof, that's why this is part 1, and we're going to go into part 2 later. And if the rectilineal figures similar and similarly described on them be proportional, the straight lines will themselves also be proportional. Let 4 straight lines, AB, this is AB right here, okay, CD, this is CD right here, EF, this is EF right here, and GH, this is GH right here, be proportional. Okay, so that as AB is to CD, as this is to this, so is EF to GH. EF here to GH here. Okay, and let there be described on ABCD the similar and similarly situated rectilinear figures KAB and LCD. Well, this is KAB here, this is LCD here. And on EF and GH, the similar and similarly situated rectilinear figures MF and NH. Okay, this is MF here. Okay, so actually it'd be MEF and whatever else letter you want to put here. And NH would be NGH and whatever letter you want to put over here. Okay, I say that as KAB is to LCD, so is MF to NH. So as this triangle is to this triangle, so is this parallelogram to this one. For let there be taken a third proportional O. Here's the third proportional O, and we're going to move this up just a little bit so you can see it. Let the third proportional O be taken here, and O has to be proportional to AB and CD. Okay, O is proportional to AB and CD. And a third proportional P to EF and GH. P is proportional to EF and GH. And this is by Euclid Book 6, proposition number 11. Then, since as AB is to CD, as AB is to CD, so is EF to GH. We've already established that. And as CD is to O, CD is to O, so is GH to P. Therefore, X equali as AB is to O, as AB is to O, as AB is to O right there, so is EF to P. EF to P. And we can prove this by Euclid Book 5, proposition number 22. But as AB is to O, as AB here is to O, so is KAB to LCD. KAB is to LCD. And as EF is to P, as EF is to P, so as MF is to NH. MF, NH. And this is by Euclid Book 6, proposition number 19, porism. Therefore also, as KAB is to LCD, KAB, LCD, so is MF to NH. MF to NH. And this is by Euclid Book 5, proposition number 11. Okay. And that concludes this part of the proof. Okay? So this part of the proof has been done and is concluded. Now I have to draw one more figure on here before I can continue with the rest of this proof. I will do that in a future video, so I want you to stay tuned for that. We've only got 11 more proofs before we get into algebra with the geometry. Okay, so we got another 11 more proofs, and then we're going to get into some really thick stuff. Alright, I will tell you more in a future video, so stay tuned.